People let's go of her balloon, and the balloon starts rising vertically at a constant speed of 15 feet per. So this way, 15 feet per second. The ant who was looking directly at the balloon starts running toward Ava at a constant speed of 4 feet per second. So ant is running at 4 feet per second on a straight line. After 3 seconds, the ant is 60 feet away from Ava, who's still standing at the same spot. At what rate the distance between the ant and the balloon is changing? And so that's the first question. Now, what do I know? I know there are two variables that are labeled in here that are related to this to part A. So for part A, the variables are x and y, and then the distance between the ant and balloon is also one of the variables. So I can call this z, I can call this d, whatever you wish, just the variable name, and let's say d. Now, what else do we know? Do we have any constants? No, we don't have any constants per se. And what rates do we know? So there are two rates that I actually know. One of them is this 4. That means that because ant is running toward Ava, the distance is decreasing. So rates dx dt, which is basically negative 4 feet per second. Feet per second. And what else do I know? I know dy dt, which is 15 feet per second. And then what is asked is dd dt is the question basically. Now, how do I relate all these? It's a Pythagorean theorem. So x squared plus y squared equal to d squared. That's the relation. Now derivative. So derivative of that is 2x, x, that was the derivative of outside, derivative of inside is dx dt, plus 2y dy dt equal to 2d dd dt. Now we have to plug in whatever information that we have. So what do I know? These two rates I know. I need to know x and y at that instance. And so what is the instance? The instance is given to be 3 seconds after the balloon starts rising, and ant is at 60 feet. So at that instance, x is 60 feet. And again, this rate is negative 4. This other rate is 15. And I need y, but how do I find y? Y, the rate of rise is y at 3 seconds is equal to 15 times 3, basically. So let's go back up. So this is how it says. 3 seconds later, and the balloon had 15 seconds to basically rise up. So it's 45 now. And now, so this one is 45. and I have to compute d through a Pythagorean theorem, so I can use this one more time to compute d. D is going to be the square root of 45 to the power 2 plus 60 to the power 2. And so d is going to be 75 if you compute it. And so this is 75. Now solve for dd dt, because all the other variables are given. You can solve for dd dt, which is going to be basically dt is going to be 60 times -4 plus 45 times 15 divided by 75, and that's 5.8 feet per second. This was part A. Now let's do part B. The next part is saying the ant is looking at the balloon, and it's asking how fast is the angle of her line of sight changing. So basically I have to connect the line of sight to two of the sides, and that's how I can find the change in the angle. And so what I can see is y over x is a very reasonable value to do. So for part B, right, tan of theta is equal to y over x. And then we take the derivative of that, which differentiation of that, and it gives me tan of theta becomes secant squared theta d theta dt, because derivative of inside equal to, now y over x is derivative of the bottom, which is the bottom times derivative of the top, dy dt minus top times the derivative of the bottom divided by the bottom to power 2. Now what remains is that what is secant of theta? If tan of theta is y over x, going back over here, d was basically square root of x squared plus y squared, and secant of theta is 1 over cosine of theta. That means that it's the hypotenuse over side. So going back, if tan theta is that, secant theta is the hypotenuse divided by x, and so secant squared theta is x squared plus y squared divided by x squared. And that's how we go back in here and we put in x squared plus y squared divided by x squared d theta. dt is equal to x dy dt minus y dx dt over x squared. Now it's the time to plug in all the values basically. And plugging in all the values is going to give me, let's say, so what was x? X was 60 to power 2, y was 45 to power 2, and x in here is 60 to power 2. Over there, again, 60 to power 2. Oh, these two incidentally simplify together, so I don't even have to compute it. And 60, this one is 15, that one is 45, and this one is -4, and so you can compute d theta dt, and d theta dt is going to be approximately 0.112